Hello everyone, here I am with yet another video on exponential growth. This time we're going to continue on our exponential formulas, and specifically we're going to see what more we can get out of growth factors. What we will do is we will have a look at how we can find a growth factor of several steps of a longer period of time, and how we can get the growth factor for half a step for half the period of time. So let's start with the several steps. For this, I will use the same example that I've used in the previous video, where we start at the distance of 8, and in this case every 10 minutes, we halve the distance, so 8, 4, 2, etc. Now, rather than finding the formula for every 10 minutes, let's say I want to know the distance per half an hour, so my formula per 30 minutes. The initial amount stays the same, we still start at a distance of 8, but my growth factor will change. Because per half an hour, I'm actually calculating times a half, times a half, times a half. And a half times a half times a half is 0.125, so that will be our growth factor. So if we fill that into the general formula, we will get that d equals 8 times 0.125 to the power of t. Of course, we can do this for more time spans. Let's say instead I want to make the formula per 40 minutes. Not the most logical number, but we can still make the formula. Then I have to make this step. And what I do is I do times a half, times a half, times a half, times a half, or 4 steps of a half. And if I shorten that, I can actually write that as a half to the power of 4. And calculating that, of course, I can get back to a decimal number again, but it's starting to get a bit long, so I will use a fraction in this case, which would be 1/16. So my formula for 40 minutes would be d equals 8 times 1/16 to the power of t. The brackets here do not really serve any purpose except to make it more readable, so you don't get confused with the power and the fraction. So it's just 8 times 1/16 to the power of t. So let's summarize this. We saw that if the growth factor for one step is g, so for instance a half, then the growth factor for 3 steps is g to the power of 3. So in this case, a half to the power of 3, or 0.125. And for 4 steps, well, same idea, it's g to the power of 4. And we can continue this pattern. For 3 steps, it's g to the power of 3. For 4 steps, g to the power of 4. So for x steps, the general amount of steps, the growth factor is g to the power of x. In this case, a half to the power of however many steps I'm taking. So that is if I want to make the time span longer. Let's see what happens if I make it shorter. Specifically, what happens if I try to take half a step. Again, I'm going to use the same example, but this time I'm only looking at the first bit. So at 0 it was 8, at 10 minutes it was 4. And I want to know what happens with half a step, what happens with 5 minutes. Now it's not linear, so it's not going to be 6. Instead, we're trying to find a certain step that if I do it times that number and times that number again, I go from 8 to 4. So if I do it times that number and then again times that number, I do it times 0.5. To solve this, let's make it a variable for a moment. Let's call it h for half. So then times a half is the same as times 0.5. So if we shorten that, that means that h times h squared, is 0.5. And if we solve that equation, we find that h is square root 0.5. Of course, minus square root 0.5 is also an answer to the equation, but we only have positive growth factor, so we only have to look at the positive solution. So we find that the step for 5 minutes is times square root 0.5. Again, let's summarize this. We can generalize that if the growth factor for one step is a certain growth factor g, then the growth factor for half a step is square root g. So to summarize the whole thing, if you have a certain growth factor for a certain step, and that growth factor is g, then the growth factor for x of those steps is going to be g to the power of x. So for instance, if your growth factor per day is 3, so every day it triples, then in a week, so 7 days, it's multiplied by 3 to the power of 7, so it's already multiplied by 2,187. On the other hand, if the growth factor for one step is again g, but I want to know the growth factor for half a step, then it's always going to be square root of g. So if the growth factor per day is again 3, then the growth factor per 12 hours, per half a day, will be square root 3, which is approximately 1.73. This is the last video that is specifically about exponential growth. I will still be making one more video in this series, and that will be about scientific notation / standard notation. And that one will conclude this series.